All right, I'm going to go ahead and get started. So we are in our um, kind of finishing our um, kind of basic data access with xarray. We're learning how to use the xarray package. And today I'm going to be focusing on accessing data that's on ERDDAP servers with xarray. And then we'll have a couple sessions on accessing modeled ocean data. And after that, as we get into May, we are going to have a series of guest lectures on some kind of different topics, special topics that you can see down here. All right, so xarray with ERDDAP. If you go, I'll post there's the link again to the website. Once you go there, if you look over on the left, you're going to see xarray with ERDDAP. I'm going to focus today on working with gridded data that's on ERDDAP and showing you how to create data cubes and do some things like process that data and create time series. However, I want to make sure you're aware of the Coastwatch tutorials. So Coastwatch has a really fantastic set of tutorials. And for those of you who are not Python users, they also cover accessing data on ERDDAP servers with R. And I think they have a few in MATLAB too. Yeah, there they have it in MATLAB too. So they've got a really great series of tutorials that they've made available. Check this out. There's some great packages for working with ERDDAP servers that facilitate some of the things that you'll want to do. Um, I'm not going to be covering those today. I am going to be focusing on how we can use xarray to interact with ERDDAP servers, with data on ERDDAP servers. Okay, but check that out. Lots of great material. I'll also say there is great material on the iUse Code Lab. If you haven't ever checked that out, lots of great stuff. And in particular, they have a package called ERDDAPI, ERDDAPI. I think it's ERDDAPI. Um, and let's see. So they have a bunch of tutorials on how to use that package. Again, not going to talk about that today. Okay, so ERDDAP. So ERDDAP is a way that a really common way that data are served. It doesn't have to be gridded data, though we're going to be working with gridded data. So gridded means like a lat long grid. That would be typical. Also serves a lot of table data. So there's a lot of I don't know. I work with glider data. That's a table data. There's a lot of that available on ERDDAP servers. And the idea behind the ERDDAP server is to um, make it easier for the end user to work with data. And I really love that about ERDDAP. They're very like kind of language agnostic. If you go to let's go to a URL and just kind of check this. Oh, darn it. That didn't render nicely. We'll go to, I have to copy this here. Here we go. So if you go to a server, um, you can, we'll just click that, see some data. So it's got this really nice interface here, and you can go look at the data, you can graph the data, that kind of thing. So it's a really great interface. And also it has, you scroll all the way down. Oh, it's not here, but I forget where it is. Um, if you poke around, they have great documentation of how to do things with ERDDAP servers in different languages. There are many different ERDDAP servers. It's an infrastructure. There's hundreds of them. And here's a list of some, common NOAA ones, but you can see a complete list here. And also there's you can search the servers. So that's nice too. Okay. And as I said, they make it really nice for the end user. There's lots of different ways that you can interact with their servers. We're going to be interacting today with Python and specifically with xarray. Okay, so the when you interact with an ERDDAP server, you can specify what you want using the URL. If you have worked with ERDDAP servers in the past, it's very likely that you are interacting with it using um, the a URL to the data like this. This is the URL to the data. And then you put question mark and you can like filter it. It's like a query. So here I'm getting chlorophyll A. The next one is what the date is. And then this part that looks to me that's probably latitude, something like that, and longitude. So it's a query there. That's a really common way that people interact with it. And a nice thing without the ERDDAP servers is you can use that URL and it'll do the subsetting for you. So you're not grabbing the whole data, you're grabbing a subset of it. But there's another way that we can interact with the data, and we can do subsetting, querying with xarray, and we can interact with the data in a lazy way. Lazy means we're not loading all the data into memory. And that's what I'm going to be showing you today. As usual, feel free to either raise your hand, I should hear a ping, or put a question in the chat. Okay, so we are going to go to this one, data cubes, and lean on some of the functionality of xarray to interact with the ERDDAP server. Okay, so I'm going to work on this through the Jupyter Hub. I did not test this out on Colab. I think it should work on Colab. However, I will say one thing. If you're on Colab, make sure to add a code cell before you do anything, before you start xarray, and install PyDAP. I didn't think it needed PyDAP, but when I tried to run this, it complained that it needed PyDAP. So you'll have to add that piece of code there. Just click a code box, put that in there, run it. If you've already started, and if you ever like start to like you've already loaded xarray and then you're like, oh my God, I've got to, add something else so it has an engine, what you do is you go into runtime and you restart the session. Then you do the pip install and do the xarray part. That's how you make sure you have the right engine for xarray. Okay. But I'm not going to do it there. I am going to do it here. Okay. So, okay. So I'm in that function, in that notebook. So ERDDAP provides two ways that you can access data. One is griddap, and that would be for gridded data sets, like your lat long time. And then you have TableDAP for tabular data sets, and those you're going to be querying by row. And what we're going to be doing today is we're going to be lazy loading in a gridded data set with xarray. And we're going to lazy load in a really big collection that's on ERDDAP. In this case, we're going to use this high resolution SST analysis, and we're going to load in, we're not loading it, it's lazy loading. Going to lazy load all the data. So let's go ahead and do that. So the format to do this is you need the URL looking like this. So here's the server here. It's going to have ERDDAP, and then you got to make sure it says griddap. If you said TableDAP, it's not going to work. It needs to be griddap. And then you're going to have the data set here, and that's it. No dot anything. It's just like that. That's going to point to the collection. And now we can say, open that data set. So let's go ahead and open that. So we're going to run that. Right. Okay. So I'm on a puny little virtual machine. I think I only have 4 gigabytes of RAM. And obviously, I did not load all this data into memory. That is 158 terabytes. Okay, so did not load that into memory. But I loaded in all the metadata, and now I can start interacting with it with the tools that we have learned with xarray. So let's go ahead and run this. So you can see it's an xarray data set, and it has dimensions. It's very high resolution, this lat long. It has our time. It's got our coordinates. That's nice because coordinates are things that we're going to be able to subset on. And then it shows us the data variables. We've got SST, CI's fraction. I think this is a landmask. We also have information, our attributes. That's always really helpful to have that with the data so we can understand what our data set is. Okay, so now that this is a xarray data set, we can do subsetting like we're familiar with. How does that look? So this is our xarray data set. So we're going to pick a variable. We need to do that first. Here's one way to do it. So put the square brackets and then the variable name in quotes, and then we're going to select. We're going to slice the latitude, 2 degrees of latitude and 2 degrees of longitude, and we're going to pick the year of 2023. So let's go ahead and slice that and look at how big this smaller data set is. Okay, there we go. That is a lot smaller. And this is small enough, this 120 megabytes, that I could load that into memory. And what I did is I actually did load that into memory. If you're following along, go ahead and click that. Hopefully I haven't restarted my kernel. Let me see here. Did I restart my kernel? No. Okay, great. Okay. Yeah, I ran this ahead of time because you can see it took like 3 minutes to load that. And it's not that big of a data set, but the whole just input output part interacting with the ERDDAP server, that's kind of the part that's taking a long time. I will also let you know that whenever you're working with like a server, like an OPeNDAP server, typically they are going to have download data access limits. When I did this part, I didn't access any data. All I did was loaded the metadata. So that was fine. But once I start doing something, and here I'm also just loading that metadata, that was fine. But right here, when I load, or if I plot, if I plot, I have to load the data too. At that point, I'm starting to download data and I can hit that data limit. Um, I don't know what it is on this particular server. Really common would be 500 megabytes. That would be common. But I don't honestly know what it is on this one. Um, so that's something to be aware of. Like if you like start running into weird, like um, it'll be weird errors that you get. It'll say something like it's an HTTP error. And if you think about how much data you're getting, you'd probably be like, oh, I took too much. So that's just something to be aware of when you're working with these kind of servers. Um, it's yeah, it's per query, like the amount of data you can get in one chunk. I'm going to show you how I'm going to process 4 GB of data using Dask and to limit the queries to like 150 megabytes. You'll see that in this example. So be aware, like this is one reason people like data that's in buckets, like in cloud buckets. So they're not going to have um, any kind of like limits. You can just like get all the data you want. I mean, it may take a little while, but there are no limits. So that's a nice thing of buckets. But if we have something that's like a server, they're typically going to have limits, which they need because they can't have like infinite connections. Okay, but we've gotten that data. We loaded it into memory, and then we can do the typical kinds of things that we can do with xarray objects. So here's our objects, and we can plot it. This is the sea surface temperature in this 2-degree box. You can see it's very fine scale. It's the nature of this data set. We can also do other things. We can compute the mean SST over the whole data set. So here we're taking mean, and we didn't put in any dimensions, so it's over the whole thing. Take a moment. Won't take that long. Go, 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 go. Oh, come now. It should not take that long. Okay. Don't know why it's taking that long. Okay, get out of here. Hmm. That is being annoying. Okay, I'm just going to stop that. Hey, stop, stop, stop. Why are you being so annoying? Oh, God. No, I don't want to restart the kernel. Why are you being annoying? Up. Great. Okay, fine, fine. I don't know why you're doing this. Okay. I have to rerun it. Okay. Okay, got that. Subset it. Okay, and this part is going to take a moment. Okay. Okay, I'm going to let that load, and I can talk through kind of the rest of this while that's loading. Okay, so when we took that mean, we were not like compressing it over any dimensions, so it had the well, step back. If we do the mean like this and we do put in a dimension, what is happening there is we are taking the mean over that dimension, but we keep the other ones. So in this case, when we have that X-ray object, we take the mean over time. It's the mean over the entire year. And if we plot that, we see we have these, we still have our X and Y dimensions. So in this case, what this is the mean temperature, SST, over the entire year for each of these pixels here. Okay, let me see if it's loaded. I can keep going here. Oh, that went faster this time. Okay. Fingers crossed. Fingers crossed. Come on. Let's get you. Oh, okay. Great. So when I did the mean here, it was the mean over everything, over the lat longs and over time. But then if I do it like this and I take it over the dimension time, it keeps the lat long because I said just take the mean over time. I can also do a mean over the spatial dimensions. So this is going to be the mean over this whole space, and then I'm going to keep the time points. So here I have created a time series for that lat long. So now I've created a time series. With xarray, I can resample to take monthly means. So that was daily. Let's do the monthly. And here's how I create the monthly. I use the resample function and then time ME. If you look up the documentation on resample, it'll show you all the different kinds of resampling it can do. It has lots of things like 1 day, 8 day, quarterly, all kinds of things that you can resample to. So that's a really nice feature of xarray. So then it did that resampling. Let's make my box a little bigger here. Okay. So there we go. So it was able to really quickly create these monthly samples. All right. So that was an example where I was working with a data set that I could load right into memory. So this one here, it was like 120 megabytes. I could load that into memory. And then once I loaded that into memory, you saw the calculations went nice and fast. What do you do if you're working with data that's larger than memory? So, for example, let's look at this example here. So I'm going to go back to my original X-ray data set. So it's the one that's pointing to the huge 128 terabyte data set. And I'm going to get all the days. So I'm still going to work in a 2-degree latitude box, but I'm getting all the data. So all the days and all the years, so not just 1 year. Let's go ahead and do that. And if we look at that, that went really fast. Again, it's all like lazy loader. It's not like working with data actually in memory. And in this case, I've got a bigger data set. And I'm working on a really puny virtual machine. I can't load all that data into memory on the machine that I'm on. So what do you do in that case? Well, when you're in that case, then you can invoke the Dask machinery to allow parallel computing. And how that works is you you chunk your data, or you tell it what chunks you want to work in. So let's look at this. Oops. Chunks. So, wait, aren't you going to show me chunks? Why didn't you show me chunks? You're wrong. Oh, come on. Well, there are no chunks. Let's look at this. Okay. So we can look, oh, it's because it's a data array. Yeah, that's okay. Okay, so there is no chunking, and I guess because there's no chunking, that my little, chunk thing didn't work. I just wanted to display the chunks, but I can display the data array, and I can see here that it's not telling me anything about chunks, which means there aren't any. So if I am going to do something like take the mean, do that mean thing that I was doing, it's going to do it on the whole thing, and it's too big for the memory. So what I can do is I can specify some chunking, and then when I do the mean, it's going to do the mean on those chunks of data. And here's the function. It's called chunk. What am I doing here? So by saying -1 and -1, I'm saying don't chunk up latitude and longitude, but chunk up the time into 500 days. I just need to chunk it small enough that it's not too massive. Okay. So here we go. So now it's chunked, and you can see it outputs what my chunking is. So it's 154 megabytes. It's probably a little smaller than I need, but that's all fine. It's fine for demonstrating. You could probably tweak that, the size of your chunk, to kind of optimize the speed. What this means is that when I apply a function now like mean, it's not going to like grab the whole 2.6 gigabytes. It's going to work chunk by chunk, and it's going to figure out an optimal way to do this mean calculation or whatever calculation I'm doing. Okay. And I'm not going to run this because it does take 13 minutes. So you saw like when I could load the data in memory, that went really fast. But now I'm working with data I can't load in memory, so I'm going to have to chunk it up. And so it takes longer, but I could run this on this puny little machine. It'll just kind of chug along, doing its work, and the memory is never going to explode. It's never going to be loading in more than 150 megabytes of memory. So it's just going to chug along. And I put a little progress bar here. You can watch it. Yeah, so I didn't try to optimize at all. I didn't set up any workers. I just let it do whatever the default was. So yeah, so maybe if I had oh, I'm on a puny little thing here. I have I don't know how many CPUs. I took the smallest one. What is it, two CPUs? Maybe four maximum. Yeah.
Yeah, I think that I only asked that question because I think that that helps actually because like you don't want to like overwhelm the like you can overwhelm an OPeNDAP server or maybe ERDDAP, I don't know. By
Hmm.
like if you tried to do like a 500 cores or something and it might just not it might not respond or think you were attacking it or something.
Yeah, yeah, definitely. Yeah, so that's a good point. Um, if so, Dask is going to spread the work over your CPUs. Like it'll figure that out, do something, kind of intelligent. Um, and yeah, if I had tons of CPU, it might hit the server too much, and um, they will block you if they think you're abusing their service. Okay. Um, but doing it like this, it works. It just takes a little while. I could do this for the whole globe, actually. It'd take a while, but it would get done, and I could process a terabyte of data slowly, but I could. Um, And here in this code, what I'm going to do is I saved it to a netcdf so I wouldn't have to run this thing for 13 minutes. And then here we can download the data and open it up. So it can be, in my experience, it's a little iffy trying to load netcdfs directly from GitHub, which is why I'm downloading it, but it's a small little file. So you can run this too, download this, and now you can see that what I've done is I've created a time series for like all these years. So I processed that 2.6 gigabytes of data in 13 minutes on a puny little virtual machine. And I can do the resampling monthly like that. All right. So before I move on, show you something a little different, show you the czar. Any questions about that? Or Rich, since you're on the call and you've done this a bunch, if you want to add anything of your tips and
I,
tricks.
I think I would just add that I like that strategy, Eli, and I think it, like you can use it for to a limited extent, like to get faster responses from the server up to whatever they scale to.
Mhm.
And
Yeah,
so not only saving, your own puny machine, but also getting more data from the service. But like, so
yeah.
you can use it at Copernicus and stuff like that too, like the same approach. And OPeNDAP, like you could, I think you mentioned last week that you can run into the 500 megabyte limit or something, but you can see how many you could load, like 5 time steps, you know, or whatever, and maybe you can get away with 10, and then 15 is too much, but 1 is too slow, so you
Hmm.
can play around with that a little bit and kind of optimize for whatever service you're using.
Yeah. Um, yeah, these data limits are a real headache for people working with these servers. Um, and it can come up where you um like you're trying to get the data and then you're like, I can't get all the data, and then you have to get it in chunks and then try to reassemble it. And this workflow here shows you how you can make that really simple for yourself by applying the chunking and then xarray when it's going out and going and getting the data to do this operation here, this mean. Here it's a mean, but imagine it could be anything. It could be a function that I'm sending to it. Um, it does that intelligently in the background and doesn't take, you control how much data it's getting from the server at once. All right. Okay. The other thing that I like about this workflow, and being able to load in that whole collection by giving it the griddap URL, is that um, since I work with Xarray a lot, I'm really familiar with how to do these kind of subsetting functions. I don't have to think about how to construct a URL. I don't have to learn a new package to help me do subsetting. I can use the package xarray that I'm really familiar with and do the subsetting, do the various operations that I'm familiar with. Okay. And I also get like the really nice features of xarray, which like like doing these means across different dimensions. I really like that. It works really, really nicely, and being able to resample to monthly or 8-day, that's really great. Okay. So I wanted to compare. Actually, I didn't run this code, so let's, if fingers crossed this works. Okay. So what we're going to do is we're going to compare the same data set that is in AWS Open Data in a xarray format. So now we are accessing data that's in a bucket. And it is the same data. It has two. So see there, it's the same thing. This sort of massive thing here. Uh, It's looks like it's got more years actually. This is 2022 to 2002 to 2020. So I think that's more than what was on the ERDDAP server. We can subset again to 20. Oh, this is 3 years. Let's go ahead and do that. There we go. Um, and now I'm going to do this because it's faster on using xarray. So when I did this kind of mean before, it took a little while. Using the OPeNDAP server, that input output was slower. And here I'm going to do the same thing with the xarray. I'm going to chunk it, and then I'm going to do this mean. So let's go for it. Okay. So now you can see how this progress bar is working. When I access the OPeNDAP server, it would be still over here. Yeah, this is going nice and fast. So it's working through it, and it's computing the means with the 500 a day chunks, and then it's going to put it all together for me when it's done. Notice here that I have dot compute. Okay, so that took less than a minute. Nice. Notice here that I had dot compute. If I didn't have that there and I ran this, it'd be like, boom, done. And you'd think, wow, that was great. That went so fast. But if you did that, if I didn't have the dot compute, what I would be doing is basically asking xarray and dask create the graph to do that calculation, but don't actually do it. So that's why it would be really fast. By putting the compute on there, I'm saying, hey, go do it, but I'm also loading it into memory. So I want to make sure whatever I'm computing, the end product is something that can be loaded into memory. And the mean all years is not like, it's just a time series. So it's fine. Okay, so we can run that. There we go. All right. Okay, I'm going to pause there again. Anything that you have questions about or that's confusing, you haven't seen this before, you'd like me to show again?
I think you kind of said it, but like sometimes if you do if you don't do the compute, it's kind of handy, especially if you're doing like a really big thing, just to make sure that the thing you're going to do is the thing you want to get, and you don't spend a whole bunch of time like, oops, that wasn't what I meant to do.
Yes. And I don't know off the top of my head how to show the DAS graph. Do you
Well, what
know?
I guess what I meant was like I don't really either, but if you did it without the compute, it would show you the array size and everything, so you could say like,
Oh,
oh,
yeah.
it has one time step. Oh, right, yeah, because that's I'm doing the mean or whatever it is, something
Yeah.
like that, just to make sure that it looks like the kind of data array that you want to get back.
Yeah. Yeah. That's a good point here. Let's just kind of do it. I don't need to do progress bar because it's going to be fast. Let's do test here. So, right. Okay.
Or even without the test equals, just to
Okay. Yeah. Okay. Right. Good point. So, gonna run that. Okay. So you see, it's like boom, really fast. because it didn't actually compute anything. And so this is what Rich was talking about. You're going to make sure, okay, yes, it's going to have this many time steps. Yay. That makes sense. I was subsetting to like 3 years, 3 or 4 years. Great. Um, there we go. Yeah. So it looks good. And okay, 3 chunks in 6 graph layers. Okay, that doesn't look crazy. Like it doesn't have like hundreds of graph layers, so that's going to be okay. So that's what he was saying about you can kind of check that just do a really quick like sanity check that it looks like the right shape before you start doing it, and then you come back, 10 minutes later and figure out that you had set things up wrong. For example, I like what if I did that? Um, then I would quickly see it's like, oh, wait a second. Why is lawn there? Lawn's not supposed to be there. And then I'd
Yeah.
be like, oh, I did something wrong. Dawn, go ahead.
Thanks. I had to find the unmute button. Can you hear me?
Uh-huh, yeah.
Okay. I just wanted to add to that conversation that the utility of compute is really neat for folks who haven't used it. It's really neat because you can do all kinds of functions on an array without actually computing it. So you can just sort of go through your workflow and do a whole bunch of different functions or whatever you need whatever work you need to do on it, and then just run a compute at the end. And you can use this like you're kind of showing here, where you can just sort of see the shape of the array to sort of check that I'll, do a sanity check on it, and then just do one final compute at the end. And so it's a little less stressful on your memory. That's all. Just wanted to add that.
Yep. Yeah. Another trick that I learned is that I want to do all my subsetting before I do any operations. So I could do, okay, I'm gonna like do the mean and then I'm gonna subset. And to me, it looks kind of like, well, it's kind of the same. But then if you look at the DAS graph, it would, um, well, in any case, like it wouldn't go nearly as fast as if you did all your subsetting first, made it nice and small, whatever you need, and then do your operations on the smaller thing. Okay.
Actually, Eli, is that true even if you just did the compute at the end, like we were just talking about? I'm not sure.
I have found it to be um yes, I found it
Okay.
much better even if the compute's at the very end, and I think it has to do something with the DAS graph.
Okay. It's just not quite smart enough to figure that out, I guess. Yeah.
Yeah.
Okay. That's good to know.
Okay. Let's see if this will load. Okay. Um, so in the last 5-10 minutes here, I want to show you a new feature for working with TableDAP URLs. So first I'm going to show you what it looks like if I just use if I load up a TableDAP URL with xarray. And you'll see that it works. Um, let's see here. I wanted to load this glider data. It was down. Oh, well, okay. Let's add a new one. Their server went down right before class, so but we'll see if it's up. Are you gonna work? Mm, mm, mm. Oh, so sad. That's too bad. Why on earth are you doing that? Okay, let's try again. Hmm. Wow. That is really okay. Try one more time. I don't know why it's doing that. Okay. Okay. How damn it. Okay, let me see if this will work. Different URL. That's too bad. Well, okay. All right. So, I'm open. Yeah, this unfortunately this glider ERDDAP server I noticed earlier in the day it's gone down, so I can't show you that. But I can show you what it would look like if I were opening up a table DAP data collection. So this is opening up some cow coffee egg count data. And you can see that xarray can still open that, but it's it's not so useful, right? It's got all the data variables. That's all nice. I mean, I could do a lot of data munging on it, but yeah, I know. I was so sad. I really wanted to show some cool glider data. I also went in the browser, Mika, and it was giving me like 403 for all the data sets. Um, all right, so if I just use the regular open URL, you can see it's not so useful. I mean, like I said, I could probably like munge it and get it to work, but with the if you load up the new version of ERDDAP, so I don't know when it was introduced. Micah maybe knows, but definitely 3.1.1. If you're on the Jupyter Hub like I am, you have to upgrade. And then if you run this, make sure you have 3.1. And then when you look at the backends, the engines, you will see we now have this ERDDAP engine. And um, I haven't done a lot of research on what this new engine allows, but I did see a notebook where someone was using it and showing how it can improve um, creating xarray objects from table DAP data. And let's see here. Let's see here if I load it. Oh, I didn't load it. Oh, so sad. Okay. Let me see if I can showcase. See if I have this. Hopefully I haven't. This is a whole cool. This is a different one. This is all showing how to use use some glider data. This is from a ERDDAP showcase, but this is what I want to show down here is so this is with this new engine, and if I was loading up the same data set but with this NCCFM on the end here. I get something that I can now start to do something with. So it has coordinates, yay. Um, and if I could click on that, it would show it has my data variables and they're not looking with this funky S thing on them. This is the important thing. It's got my data, my coordinates there. So it's all ready. I can do things. Once you have coordinates, you can start to do things like subset coordinates or take means over coordinates. You can select specific trajectories. This only has one, but you can imagine maybe it would have multiple. You can start doing things like that. So yeah, so that's something to watch. It's a new feature for the ERDDAP um, package. And as I said at the beginning, if you go uh, here, there are a bunch of tutorials about that package, and you can learn about, its features. Okay, I'm going to stop there. Yeah, Micah, please.
Yeah, I just wanted to mention quickly. So too bad about the glider DAC not working, but normally that should be up and running. I'm not sure what's going on there. But this, yeah, the ERDDAP engine for xarray is just pretty, recent, probably within the last month. But I've had some conversations with Felipe Fernandez, who did, basically maintains the ERDDAP package, and added that new functionality, about whether it's possible potentially to enable some type of lazy loading for TableDAP and ERDDAP. So I think that's unknown, but it's something we've talked about, and potentially, if it's technically feasible in the future, could be supported. So, that would help with basically being able to enable like a similar capability to what you're showing with the griddap URL and TableDAP. So no promises, but there's at least some ideas being thrown around. But that would be, of course, on the ERDDAP side to implement
that. Brendan.
Hi, Eli. Can you hear me?
Mm-hmm.
Okay. Sorry, I missed something on the czar. Looked like you were using the same dask function for both the ERDDAP and the czar, and they both were reading netcdf. Where was the efficiency of czar running about 10 times faster? Was it a different engine that netcdf was using?
The engine would be the input-output step. I mean, the speed up would be the reading the data.
So was it reading a different data set from the ERDDAP? That's I'm sorry, I'm missing where
okay.
the efficiency was.
So the ZAR file is on AWS OPeNDAP. It's in a S3 bucket there. So it's a different data serving technology infrastructure. It's not like an OPeNDAP server. And you can like the way I think about these different types of servers is like, so an OPeNDAP server is kind of like going to a restaurant. It's got a lot of like extra features to it that make it really nice, and they can create a really nice product for the end user. But there is some like extra processing, extra work that needs to happen on their side. And the bucket is just like exposing the data. And there's nothing that's happening with the bucket. There's no work that's happening on the bucket side. It's just like exposing it, and I can point my function at it and just grab the data. But it's not doing anything else for me.
And I guess you could.
Yeah.
Oh, I was just going to say you could add. I guess that on the bucket side, the all those, like, the cloud is made for those like lots of connections all at once, and so even if you only have a few CPUs, but they're like doing asynchronous requests for the data and stuff, it just moves a lot faster. And if you have more workers and they're all asking for data at the same time, and it's just no problem, but the server gets overloaded. I think you kind of said that, but
yeah. Right. Yeah. So that's a nice thing, like with the buckets. It's basically I could have infinite connections. It's not limited by connections, but the servers, they are multi-threaded. You can have more than one connection, but it is finite.
Thank you both for the explanation. It was my understanding that the file was already downloaded when you're processing, and you're not accessing real time. So now it makes total sense. Thank you.
Yeah. Yeah, I was accessing real time and I was accessing something that was larger than the memory of the. So I was working in a Jupyter Hub that was pretty tiny. And the data I was accessing would have crashed my kernel, would have crashed my machine because it was tiny memory. And what I was doing was telling kind of xarray to chunk my data. And then once it was chunked, and then when I did an operation, it would go and get the data in these chunks so that I never got more data than my memory was able to handle. And also, I didn't get more data than the server would give me.
Thank you so much.
Yeah. All right. Well, everyone, hope you have a great weekend. And we'll be back next week. We're still talking about xarray, and we are going to talk about ERDDAP again, but we're going to move into working with some modeled ocean data.